All right, so when we're writing our products over reactants for our values of K and Q, we have to be a little bit careful because as we'll see, not everything's going to be included. So let's take a look at homogeneous or homogeneous equilibrium. And so in homogeneous equilibrium, everything's in the same phase. Right, usually here we're talking about things in solution. So aqueous stuff, for example. So for example, if we have HF, hydrofluoric acid, aqueous, and then we react that with water, a liquid, you obviously know that this is going to act as an acid. And so we can write H3O plus aqueous plus F minus aqueous. And conversely, if we have a base, something like NH3, aqueous, reacting with water, that's going to absorb that proton. It's going to act as a base. We'll have a product of NH4 plus and OH minus, right, where these two things are aqueous. And so I'll give you the KQ for both of these, right, the equilibrium constant. So for this one, it's H3O plus times F minus, right, the two products, both coefficient of 1 over HF. And then the KQ down here is NH4 plus times hydroxide over NH3. And so you may notice here that something's missing. Right, in both of these we have water, but we do not see that in our KEQ. We do not see the water there. So that's the H2O is missing, right? What's missing? It's the water / the solvent. And so here's a rule when we're writing these equilibrium constants, we ignore liquids and solids. So we only have aqueous stuff or gases in our equilibrium constant. And the real reason why it is pretty complicated, and it's because these aren't actually concentrations, they're what's known as activities. But we're just going to say that their relative concentrations don't change as they are in large excess in case of the water or the liquids, right? You've got so much of them that basically their concentration is not changing, or they must dissolve first. In the case of solids, they must dissolve before they react. And if you think about that, so the concentration will then stay fixed because as soon as it dissolves, it reacts, and then more will dissolve. But more won't dissolve until the stuff that has dissolved has already reacted. So again, the key rule here is that you need to know is just to ignore liquids and solids when we're writing these equilibrium constants. And so the same thing is true for heterogeneous equilibrium. And so in this case, the reactants and products will be in different phases. But the same rule applies here. We're just going to ignore liquids and solids. So for example, if we had lead chloride, PbCl2, as a solid, and then we're going to dissolve it in some water, we'll get a dissolved compound of lead 2 plus aqueous plus 2 chloride minus aqueous. And so if we write the K here, again, we're going to ignore the liquids and the solids. So the lead chloride is a solid, the water is a liquid, so we're going to ignore that. So this will just be Pb2 plus times the concentration of chloride squared because of the coefficient. Another example here, we have calcium oxide as a solid reacting with CO2 as a gas to form calcium carbonate, CaCO3, as a solid. Here, our product is a solid, so we're gonna ignore it. So on the top, we're just gonna have a 1 there because we're ignoring the solid. The calcium oxide is also solid, so we're gonna ignore that. So the only thing we care about here is the concentration of CO2. So the equilibrium or the value of K here is just 1 over CO2, which you can rewrite as CO2 to the power of -1. Either answer is fine.